now at something that you can use in two different ways that we graph lines, which would be the t-chart method, and we're going to also look at slope-intercept in a future and soon in the future video. And in each case, you need to isolate y. So I'm going to demonstrate that you can isolate y before graphing a line. If you use intercepts or drop 2 points in there, then you don't need to isolate y. But otherwise, you need to isolate y, and I've already advised people you need to be good at isolating y to be able to rely on doing this. Here are the steps to isolate y. What I'm going to go with the assumption is you've already gotten the equation to the point where there are no more parentheses in the equation. You might have x's and y's as well as numbers involved, and that's all that I assume. There might be x's on both sides, y's on both sides, whichever. But you're going to, number one, you're going to get all your y terms alone on one side of the equal sign, therefore on one side of the equation. After that step, we're going to divide all the terms by y's coefficient. That means all the terms, including the number term, every single term, usually there are 3, but not always, will be divided by the same number. And I actually have you write that out, writing each term separately. If you do number 2 and 3 together, you don't have to write it twice. And what you should do is divide each term on its own. Don't do it with them all over one big bar. And then 2 and 3 are kind of taken together, so it's really, that's the second step. And the third step is to reduce each term. Then we're going to go through the t-chart to graph it. You will then be able to go back and look at isolating y to use it for y equals mx plus b when we learn that method. Here's the first one. It says graph 12x plus 3y equals 27. 27 does not divide by 12 evenly, so it's not good for intercepts. And therefore what we have to do is go ahead and take the 12x plus 3y equals 27. We need to get the y term alone, so 12x has to get out of this side by doing negative 12x on each side. That's gone. We're left with 3y equals the negative 12x first plus the 27. And we divide each term by 3 because we got the y term alone when it said 3y equals negative 12x plus 27. Done with step 1. Divide all terms by y's coefficient. There's a 3 under the 3y, 3 under the negative 12x, and a 3 under the 27. We wrote each term separately. We already have that, so that's great. If you have that in mind, it happens right away. Reduce each term. This is just y. This is negative 4x. And then this is plus 27 over 3 is 9. We go over here, we get x and y, and we set up our t-chart. If we were doing slope-intercept, then you'd go ahead and say the slope is negative 4 over 1 and the intercept is 0, 9. That may make sense to you already, or if you're looking back at this later. But right as it fits in the sequence of how I'm teaching it, x's are going up by 1. There's no fraction in front of x where the slope will appear. So we're going to go ahead and jump by 1. So we're going to go 0, and then 1, and then 2. And that means in each case, I'm going to go with y equals negative 4 times my number plus 9, y equals negative 4 times my number plus 9, and y equals negative 4 times my number plus 9. I got to go in with 0. And that gets me 0 plus 9, so I get 9. And I get the point 49 for my graph. Now the next one that I get is to put in 1, right? I'm doing the t-chart, but now I've got it where it says y equals. It started not having y equals, and that's the key to what we're learning new here. That gets me negative 4 plus 9. Remember to use your calculator if you need to, but you've got to deliver the point for this, which is 1, 5. And finally, we have this one where we've got x is going in as 2, and we're going to find the y value. We're going to put in x as 2, and we get negative 8 plus 9, we get 1. And so when 2 goes in, out comes 1, and then that'll be graphable. I'll just do a small version of it here. It's going to be kind of tight, but it's okay. We got to get up to the 9s. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Pretty close up there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here we go. We have 4, 9, 4 to the right, and up 9, which is the top. We have 1, 5, 1 to the right, and up 1, 2, 3, 4, 5. And we have, nope, that was bad. Doy. My mistake, this is not 4. We can live with that. That would be something I would do in purple. What I'm doing is, that's 0, 9, always has been, will be, that's 0, 9. 0 cross 9. Okay, mistake that someone might make. That would have made a triangle, we would continue. But I caught it before I got too far on the line, literally. 1, 5, 1 to the right, 1, 2, 3, 4, 5, that one was correct. And 2, 1, 2 to the right and 1 up, and that's like that. We're gonna get a line, looks something along the lines of this. The key to this new stuff is isolating y. Here's another one. Negative 6x plus 3y is negative 15. 15 divided by 6 does not divide evenly, so that's making this not good for intercepts either. So we'll start with our negative 6x plus 3y equals negative 15. I will now add 6x. So then I get the 3y alone. The first step is to get the y term alone. And so I have to do what's necessary, so 3y is by itself. That's adding 6x, so the 3y is now by itself. I have my positive 6x plus my negative 15. In order to get y alone, I have these two things going on. Writing each term separately, let's divide all the terms by the 3. Divide by 3, divide by 3, divide by 3. Let's come out of here with y equals 2x plus negative 5. Let's get a t-chart. The slope would later be 2 over 1, the y-intercept would be 0, negative 5, but isolating y is a key to that as well. 0, 1, 2. And so now when I go ahead here and I'm putting in 0, each time it's going to be in y equals 2x minus 5, so y equals 2 times my number minus 5 or plus negative 5, y equals 2 times my number plus negative 5, y equals 2 times my number plus negative 5. 0 goes in, 0 plus negative 5, subtract and get a 5 strong on the negative, 0, negative 5. Second one, putting in a 1, 2 plus negative 5. Subtract for 3, strong on the negative, 1, negative 3. So 0.1 for x, negative 3 for y. Third one, putting in 2, I get 4 plus negative 5. Subtract for 1, strong on the negative, I get negative 1 for 2, negative 1. So what you're seeing is having isolated the y has got me in a position to do the t-chart with 0, 1, 2 in each of these cases. So now I'm able to graph that one over here. Sketch of the graph anyway. I got to go out to the 5, so that's not too far. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 0, negative 5 is, don't go across at all, but go downward until you hit negative 5. 1, negative 3, go to the right. 1, go downward till negative 3. And 2, negative 1 goes 2 to the right and downward 1. We've established this. I'll quickly describe the 2 lines on the board. The one we found up there goes above the origin, downhill, missing quadrant 3. This one's actually below the origin, going uphill, and it misses quadrant 2. And so we have those two. But what we're looking at really on this video and the fit that it takes with all the others is how to isolate y and get onward to our next steps, such as the t-chart, or once we've mastered or started to learn y equals mx plus b, how to do slope-intercept. So sometimes we get our isolation done and we still have a fraction sitting in front of our x. You know about slope? If you've learned about slope, the value in front of x once y is isolated is called the slope. So if the slope is a fraction, then what that means is we're going to jump by something other than 1. We're not going to go 0, 1, 2. But the isolating of y is still done the same way. Then when we get to that point, we switch over to thinking about what to use for our jumpers. Let's try here to graph, at least sketch the graph. Negative 3x plus 2y equals 8. I think this is out in the homework video already, but let's see what we're going to do. 8 divided by 3 is going to give me a problem because it's 8 thirds, 2 and 2/3, and that's a tough one to graph. So here we go. We're going to take our isolation of y by getting the 2y alone. Got to get this negative 3x off this side. So we have our negative 3x plus 2y equals 8 plus 3x plus 3x. I'll advise, always rewrite it. You want to be able to see your original line without it all cut up by the work that you did. So you want to rewrite it before you get to work on it. Now that leaves me with a 2y equals, and I have a 3x as well as an 8. Both are positive over there. I like to write the 3x right after the equal sign because when I divide each term by 2, I'll see that y equals 3 over 2 does not reduce. Here's my x plus 4. Luckily, that's a 4. I would not want to have that be like 7 over 2, which is going to have a decimal for graphing the point. That's annoying, and we try to avoid it. But 3 over 2 is fine because we can jump our way out of trouble. How? Like this, x and y, 0 for sure. But then we're going to jump by 2. 0 plus 2 is 2, 2 more is 4. We're going to hit those. So we're going to have our y equals, and it's going to be 3 over 2 times my number plus 4. These are the jumpers that aren't 1. 3 over 2 times my number plus 4, y equals 3 over 2 times my number plus 4. My number is going to be 0. 3 times 0 divided by 2 gets me a 0 plus 4 for 4. One of the points is 0, 4. Another point, I'm going to put in 2, not 1, 2, because of the jumping that we've decided to do. 3 times 2 is 6, divided by 2 is 3. We're going to get 3 plus 4 for 7. And now we're going to put in a 4. And on this one, we're going to get, after we put in 7 and generate the point, when 2 goes in, out comes a 7. We're going to go ahead and put in our 4. Putting in 4. 3 times 4 is 12, divided by 2 is 6 plus 4 for 10. Now that might jump off my screen, it might jump off the space that I have, because 10 is pretty far out there on the number line. It is a point on the pathway. If the pathway reaches that far, it's fine. So I'm going to go say, all right, let me jump backwards from 0. Instead of going plus 2, let me go minus 2. 0 plus negative 2 is negative 2. And let me try that one. So I'll do an extra one up here. Y equals 3 halves times my number of negative 2 plus 4. Okay, so we've got 3 times negative 2, negative 6. Divided by 2 is negative 3 plus 4. Subtract and get a 1. Strong on the positive, I get 1, negative 2, 1. So when I go to graph that, I'm going to graph 0, 4, 2, 7, and negative 2, 1. 0, 4, 2, 7, and so I need to go out to the 7s to get that done. And I'm ready to go 0, 4, 1, 2, 3, 4, okay. 2, 7, which will fit, 2 to the right, and I'm purposely making a mistake here, turns out. I'll catch it later, but let's go. 2, 7, so 2, 1, 2, 3, 4, 5, 6, 7. All right, maybe that's my line. Then I go on here and I go negative 2, 1, which is negative 2, 1. Okay, that makes a triangle. If you look, something went wrong. Maybe you saw what I did wrong. But now I'm going to say, all right, I got to use the 410 now. The 410 is something that I wasn't going to use if those three lined up. But the 410, which is kind of off my graph, is going to need me to do that now. So 1, 2, 3, 4, and I'm up to 7, 8, 9, 10. And then I can see that these are all good. And that one was wrong. And I don't need to know why. Maybe you can tell why that one was wrong. This is 0, 4. 0, what kind of 4? 0, positive 4. So that should be 1, 2, 3, 4. That should be right about there. That would be in line. So if you make a mistake with the T-chart, it has an opportunity to correct itself. You don't have to know why you made the mistake. You just have to find it and go work around it with the other points that you have. So a couple of reasons there. You might want to know how to use negative 2, 1. Because 6 going in there, it's going to get me 6, 13. Still on the line. It's going to be up here somewhere. So it is possible that you'll make a mistake and you'll recognize that, as they say, mistakes were made. I love that, mistakes were made. Because you don't have to say who made the mistake, what mistake was made. You're just admitting something's not right. Politicians use it all the time. And with the T-chart method, we get to do that. One more. We'll try 5x minus 4y equals 16. So 16 divided by 5 would be having a fraction. I don't want to do this with intercepts, so I'll write it again. 5x plus negative 4y equals 16. Subtract the 5x, because the y has to be gotten alone. So it's really adding negative 5x. So here I still have negative 4 with my y equals negative 5x plus 16, divide by negative 4, divide by negative 4, divide by negative 4. What I've done there is getting the y term alone as negative 4y equals the other two terms. And then I'm dividing where they sit, each one by negative 4. So then I come out of here with y, opposite of negative, 4 over 4 is 1, so I just write the y. Opposite of negative, I get 5 over 4, an unreducible fraction, x. Remember, you don't want 1 1/4 there, plus negative 4. Then I can go do my t-chart. Begin with 0, because negative 4 lets me do that. And I'm jumping by 4, so I'll go to 4 and 8. So if you want to practice your t-chart stuff, then you'd go ahead and put in 0 for x, 4 for x, and 8 for x, and get your 3 points. We'll do that in a minute. If you know slope, you'll be able to go to the point 0, negative 4. That's going to be one of the points we have, and then go up 5 and down 4. Up 5 to the right 4 using slope, the way we work with slope, as we'll learn shortly. So here's what we've got. Y equals, we got to get 5/4 x minus 4, or plus negative 4. Now instead of x, it never works well, right? Any job is easier with the right tool. Put in 0. Y equals 5/4 times not 1, 2, or 3, but 4 plus negative 4, and y equals 5/4 times 8 plus negative 4. Okay, this is 0 plus negative 4 to get me negative 4. This is 5 plus negative 4 to get me positive 1. Subtract for the 1, strong on the positive. And this is 10 plus negative 4, which is going to get me 10 minus 4 for 6, strong on the positive, and that's going to get me 6. So I get all the points that I need. I get 0, negative 4. I get 4, 1. And I get 8, 6. And those will go on my graph. And I have 0, negative 4. So 0 cross down 1, 2, 3, 4. 4, 1 to the right, 1, 2, 3, 4, and up 1. And 8, 6 to the right, 8 and up 6. There you go. So you've seen some more of how to do the t-chart method, but what do you do if it doesn't say y equals? We begin with isolating of y. Okay, that's it for this lesson. See you next time.